British engineer designed an aircraft that flew slower than a helicopter. It cost a quarter as much to run. It had 270 degrees of panoramic visibility, and it looked exactly like a giant insect. Then he sold it to police forces, pipeline patrols, and coastal watchers around the world. The production line was hitting full speed. The future looked absolutely brilliant. And then, just 2 years after certification, one crashed in Hampshire and killed 2 officers. 2 years after that, the factory burned to the ground in an arson attack that has never been solved. Today, we explore the story of the Edgeley EA-7 Optica, an aircraft so revolutionarily designed that it completely changed how we think about low-altitude observation work. An aircraft that was destroyed not by its own failure, but by 2 catastrophic events that no engineer could have anticipated: a tragic accident and a mysterious fire that remains unsolved to this day. If you're fascinated by aviation history, brilliant designs that pushed boundaries, and the stories of engineering that defied convention, make sure you hit subscribe and turn on notifications. Now, let's dive into the story of the aircraft that looked like an insect and almost revolutionized aviation worldwide. The problem: how to observe from the air without spending fortunes. In the late 1970s, police forces, coast guards, and pipeline operators around the world faced a genuine problem. They needed low-altitude aerial surveillance without breaking budgets. Helicopters were the obvious answer, but they had critical problems. A helicopter cost approximately £500 sterling per hour to operate in 1978, an impossible sum for local police departments. They were incredibly noisy. Anyone on the ground could hear a helicopter approaching from kilometers away. Covert surveillance became impossible. Worse, visibility from a helicopter wasn't as good as people imagined. Rotor masts, engine housings, and transmissions all sat between the pilot and the sky, blocking crucial views. What the world needed was an aircraft that could fly slowly like a helicopter, cost as little as a small airplane to operate, be quiet, and provide unobstructed visibility. A British engineer named John Edgeley decided to solve that exact problem. The engineer, John Edgeley's radical vision. John Edgeley was a British engineer who had worked on military helicopters for Westland. But he had a different mindset. He didn't want to simply improve what existed. He wanted to completely reinvent aerial observation. After Westland, Edgeley returned to Imperial College London for his postgraduate degree. There, he began drawing the aircraft that would define his career. His idea was revolutionary: design the aircraft from the observation perspective outward. Put the pilot and observer at the front in a hemispherical perspex bubble. 3 seats side by side, 270 degrees of panoramic view. Behind the cabin, a 5-bladed fan inside a ducted enclosure kept blade tip speeds low, drastically reducing noise. A flat 6-piston engine powered it. Twin booms ran back to 2 small rudders, fixed landing gear underneath. The result: an aircraft that looked exactly like a giant dragonfly. The press called it the Bug-Eye. The name stuck permanently. From paper to reality. Prototype development, wind tunnel testing started in 1975. Prototype construction began in 1976 in London. But the real final assembly happened at the College of Aeronautics at Cranfield, a legendary institution of aeronautical research. The design was revolutionary. Cockpit first, engine last. Designed from the view outward. Every decision was made asking, how do we see better? How do we fly slower? How do we reduce noise? And then, on December 14, 1979, the crucial moment arrived. Test pilot Angus McVitie took off from Cranfield Airfield with the prototype Optica. The aircraft flew exactly as Edgeley had designed it. Slow, stable, startlingly quiet. The measurements confirmed something extraordinary. The Optica was considered the world's quietest powered aircraft at that moment, reaching only approximately 65 decibels at loiter altitude. That's genuinely quieter than a heavy lawnmower. People in the cabin could maintain a normal conversation at pub volume. Evolution. From prototype to production. The original prototype used a Lycoming O320 engine of 160 horsepower, but testing quickly revealed the engine was underpowered. For the production version, Edgeley installed a Lycoming IO540 Flat 6 of 260 horsepower. The same engine family used in larger single-engine aircraft like the Cessna 210 Centurion and Piper Saratoga. The production Optica specifications were stunning. Wingspan just under 40 feet, length around 24 feet, cabin width of 5 feet 6 inches. 3 people could sit shoulder to shoulder up front without touching. Empty weight, around 1,000 pounds. Genuinely light, roughly the weight of a small hatchback stripped down. Loiter speed was 70 knots, approximately 80 miles per hour. Slow enough that a decent cyclist could hold the aircraft's cruise on a straight road. That was exactly the point. The Optica was designed to observe, not to travel. Stall speed was 58 knots, around 67 miles per hour. And the endurance, up to 8 hours in the air on a single tank of fuel. That's genuinely a lot. About the length of a full working day. The Optica could stay over an incident for nearly 3 times as long as a comparable helicopter. And it did it with approximately 1/3 the fuel burn. Fuel economy that shamed every helicopter on the market. The Triumph, Optica in service. At the 1981 Paris Air Show, the Optica announced its first production order, 25 aircraft. In 1982, investors established a production line at Old Sarum Airfield in Wiltshire. The Optica received UK certification on February 8, 1985. By year-end, it was in service with Hampshire Constabulary, Welsh Constabulary, Victoria Police in Australia, and pipeline operators in Texas and Saudi Arabia. Pilots reported the aircraft was startlingly easy to fly. The Optica was simply the best aircraft ever built for the job. Operational advantages were genuine. Loiter altitude of 500 to 1,000 feet, endurance of 8 hours, 270 degrees of visibility, and operating costs at 1/3 of equivalent helicopters. Noise at ground level was so low that targets often didn't realize the aircraft was overhead until it had already photographed them. The Optica was covert in a way no helicopter could match. Every police force with a budget for aerial support was suddenly a potential customer. The catastrophe, the Hampshire crash. Then something changed everything. May 15, 1985. Just 3 months after UK certification, a Hampshire Constabulary Optica was airborne over Ringwood, Hampshire, on a low-altitude observation sortie. On board were a police pilot and an aerial photographer, both serving members of Hampshire Constabulary. Something went wrong. The aircraft entered a stall during a banked turn at low altitude. Recovery was impossible. It crashed. Both occupants were killed on impact. The UK Air Accidents Investigation Branch spent months examining the wreckage. Their report found no mechanical fault, no structural failure, no jamming of controls, no engine problem in the traditional sense. The cause was determined to be loss of control at low altitude, probably due to a stall in a high angle of bank turn. In plain language, pilot error under pressure. Not the aircraft, not the design. The investigation confirmed the aircraft was mechanically sound. But the finding didn't matter for the company's survival. The problem was public perception. 2 police officers had died in a bug-eye plane that news headlines had described 3 months earlier as revolutionary. The crash spooked the investors. Orders paused. The small aircraft press latched onto the fact that a police Optica had killed 2 people just 3 months into its service life. Whether the crash was the aircraft's fault stopped being the point. Investor confidence was gone. In the mid-1980s, a startup aviation company with a headline-making fatal accident had almost no chance of raising follow-on funding. Edgley Aircraft Limited went into receivership within months. John Edgley himself, the man who designed the aircraft and started the company, was forced out. That was genuinely a brutal outcome for what the AIB itself had confirmed was not an aircraft failure. The fire, the unsolved arson attack of 1987. New investors reformed the business as Optica Industries Limited. By late 1985, production restarted on the strength of remaining police force pre-orders. 15 new Opticas were built by the end of 1986. Genuinely a serious effort to restart the program after the crash. And then, in the early hours of January 16, 1987, someone set fire to the Optica factory at Old Sarum Airfield. It was arson, deliberate, not a workshop accident. Between 8 and 14 aircraft on the factory floor at the time were destroyed, depending on which source you trust. Production tooling was destroyed. Jigs were destroyed. Most of the in-progress airframes were destroyed. To this day, The perpetrator has never been publicly identified. For such an unusual and high-profile aviation crime, that's genuinely strange. Speculation over the decades has ranged from a disgruntled former employee to a rival aviation interest to insurance fraud gone wrong. None of the theories have ever been proven. What is verified is that on that January morning, the future of the Optica program was reduced to smoke over the Wiltshire countryside. Optica Industries could not recover. The business dissolved. The Optica program was essentially finished as a manufacturing operation from that single night. The aftermath. Attempts at resurrection. Assets were picked up by Brooklands Aircraft Company Limited, which relaunched the design under the name Scoutmaster. 9 more aircraft were built and delivered by 1990, but sales remained thin. The design then went to Brooklands Aerospace Group, then FLS Aerospace, based at Bournemouth, then to a series of investors, none of whom actually put the aircraft back into production. Each successive owner of the design rights faced the same fundamental problem. Restarting a certified aircraft production line from scratch was genuinely prohibitively expensive. But some examples of the Optica survived. 8 airframes are known to survive from the original production run. 5 of those could be made airworthy. 2 are actually flying regularly right now in Sydney, Australia, registered as VHBMC and VHBIA. Both moved to Bankstown Airport in New South Wales after their original base at Houghton Park was closed, currently owned by the Waterhouse family. In the United Kingdom, one Optica is regularly flying. G-BOPO, owned by John Edgley himself. In 2007, Edgley bought back the design rights, tooling, and 3 surviving airframes from previous owners. He formed Aero Alvara Limited with 3 former Edgley aircraft employees, Chris Burley, Finn Coulson, and Dave Lee, all part of the original team. G-BOPO returned to service on June 3, 2008. It has been the UK-type demonstrator ever since, displayed at major air shows including Farnborough in August 2008, Shuttleworth Evening Air Show in June 2010, Paris Air Show 2015, and Jersey International Air Display in 2024. In the United States, one Optica is registered to PRS Services of Spring Hill, Florida, genuinely still legal to fly for observation work. 40 years after the crash that broke the program, examples of the Optica are still doing the exact job they were designed for. What killed the program? 3 brutal factors. 3 genuinely brutal factors killed the Optica. The first was the Hampshire crash. Not because it revealed a design flaw. The investigation confirmed the aircraft was mechanically sound. But because it happened 3 months into commercial service, killed 2 police officers, and destroyed investor confidence in a genuinely fragile funding pipeline. Startup aviation companies live and die on the confidence of institutional backers. Losing 2 officers in a public accident kills that confidence overnight. The second was the arson attack that finished off what the crash had started. No factory means no aircraft. No aircraft means no revenue. No revenue means no chance of restarting. Every subsequent owner of the design rights ran into the same problem. Restarting a certified aircraft production line from scratch is genuinely prohibitively expensive. The third was market timing. By the time each new owner tried to relaunch the Optica, unmanned aerial vehicles had started to appear. The roles the Optica was designed for, the low-cost observation missions, were exactly the roles drones would eventually dominate. By 2017, when various companies tried to relaunch production, drones had already made the Optica's core value proposition largely obsolete. A police force with a budget for observation now had cheaper, quieter, safer options. The market had moved on. Final verdict: an excellent failure. The Edgley Optica was genuinely one of the most technically successful but commercially failed aircraft of the 20th century. Visibility better than any helicopter. Endurance 3 times longer. Noise footprint quieter than a heavy lawnmower. Operating cost 1/3 of a helicopter. Genuinely useful. Genuinely loved by every pilot who flew it. And yet the aircraft failed commercially twice from causes that had nothing to do with the design itself. A crash caused by pilot error. An arson attack that has never been publicly solved. A commercial environment that eventually made the entire mission obsolete. Most bad aircraft fail because they are bad aircraft. The Optica failed while being excellent at everything it was designed for. That's a rare failure mode in aviation. John Edgley himself is still trying, still flying G-BOPO at UK air shows, still holding on to the design rights, still hopeful that a modern relaunch, perhaps with diesel or hybrid power, could put it back into production. For a 60-year-old design that has watched its market get eaten by drones, that's genuinely optimistic. But then John Edgley designed an aircraft from the view outward and built a company from an Imperial College postgraduate thesis. Genuine optimism is what he does. The legacy of the Edgley Optica is a brilliant demonstration of engineering that was destroyed by circumstances beyond the designer's control, yet continues flying today in a few corners of the world as a testament to one engineer's revolutionary vision that refused to accept conventional wisdom about how aircraft should be designed.